It is an underground biogas plant which uses geothermal heat to generate gas. Now, if we may start, generally this biogas plant uses various kinds of biomass waste, ranging from kitchen waste, or rather what we term as food waste from the kitchen, which may compose of kitchen food remains. Then we have vegetable peels, fruit peels, and all sorts of food remains which comes out from the food processing or from the cooking aspects. Now, when you look at this, I may take you through about the main compartments that we have of the biogas. Here is the dome plant. The dome plant here, the main dome plant. Already we've captioned it. It is buried underground. When you look at this thing, this is the gas outlet, the gas outlet pipe, which goes towards that end. We have what we term as the feeding point, the feeder point, where we load our biomass waste to enter. It enters through the underground pipe into the dome. Of course, the dome takes a whole region, the whole region you are seeing here. Now, actually here, we have the expander or the sludge area. When the feedstock, the gas has been extracted from the feedstock, it comes out through what we term as the expander. The expander ranges from this side to this side here where I'm standing. This is the expander. This expander, the checkpoint is here. We have the materials which have come off the main dome, that is the main digester. Those are the kind of materials which have been digested already. As you can see, this liquid is just water, it's colored water. So the whole solids of the feedstock have been crushed. Now, after the expander, we have what term as the compost pit. So in this case here, we don't let materials get into the environment. That is now, a bit which holds the materials which comes off the expander. Why we are doing that is because we want to recycle it back to enhance the gas, because it composes a lot of microbials, and already the digested material is now ready. It's more ready. You can see there it has some gas components. So you can see some purple. So we normally recycle it back. We don't use any other fresh water, but we recycle this and back into the dome. So this is the expander area. The expander area. No, not the expander area, but we are talking about the kind of compost pit which holds our digested material. And remember, this is already fertilizer. This is already organic fertilizer to be taken to the farm. It can be used as a liquid, foliar fertilizer, because it has pesticidal, properties. Or at the same time, it can be used as the normal, root fertilizer. If I may get some bit of it. It is just water. It's colored water, which normally gets pumped. We normally use a pump. Can you see here? You can see it is just water which is ready. But this is a very nice fertilizer. It's a very nice fertilizer. And remember, when you run a biogas plant, normally you discover that those pathogens, the bad microbes cannot exist in this kind of scenario. Now, I want to take you now systematically, starting from the feeds, the biogas feeds that we use here. Okay, we use various compositions or various types of feeds. Here we have what you can see here is a dried kind of manure. The dried kind of manure. We don't use fresh manure, like you can see here. This is dry cow dung manure, which is mixed with sheep manure or droppings that we normally use. We again use chicken droppings, and in this game we normally do co-digestion. We don't do a single digestion, we do co-digestion, where we use all types of biomass waste. This is one component. So when in any single loading, we do a mixture kind of a feedstock. And of course, here you can see we have some banana waste, materials or waste. This is this banana. You can see this is the cellulose from the banana. We do load that. This is cutty grass. We do mix that also. Like if you have weeds, you can still generate biogas from those. But the spirit is you use a co-digestion model where you are digesting so many feedstocks together. In that way, you enhance gas production. Sorry. Now, sometimes wherever you have farmers having some crop waste, like cabbage, if there is a lot of cabbage in the market and guys do not have a market, and they may get destroyed in the farms, they can convert it into biogas. They extract the biogas as they get manure again to take back to the farms. Remember, when you are running biogas system, a farmer does not lose out, because in fact, if anything, the farmer gains by generating biogas. At the same time, gets fertilizer for the farm, which is organic fertilizer for the farm. You get the green energy as you get your organic fertilizer for your farm. So all these are feedstocks, and if you check here properly, you will see these are banana peels. You can see there, these are banana peels, which have been put here in readiness to be loaded into the system. Now you can see there all those sacks are containing animal droppings, starting from the kitchen, the chicken. You talk about cow dung, then all those you can see feedstocks which are in stock and they are dry. Those ones are dry. We do operate. We have stocked them, and they will help us run the process. Now, once you have them in that dry format, before you load them into the biogas plant, you have to soak them. Here, we soak them in what we term as feedstock holding tank. It's just holding feedstock for which are ready to be loaded into the biogas through the loading area. You can see there. Now I may want to take you to the kind of kitchen waste that we have, non-composting waste. We separate it here, and then here we get what we term as, composting. Composting waste which is able to be digestible, which is able to be digested in our plant. So you can see it is a mixture. There is ugali, or what we term as food waste. This is food waste, like this ugali. These are peels. We have peels there. That is fruit peels. We have eggshells. Like when it will add a lot of calcium into our biogas system, because calcium carbonate is very important in biogas, in biogas generation. So this brings on board that. You can see some banana, you can see some all sorts of this, like these vegetable peels, which helps in one or the other. So this, now the beauty of this, when we are collecting this, we do collect this feedstock in an airtight container to avoid it smelling around. So it is normally airtight, but this one is full, and normally this one takes around 2 to 3 weeks to be full to this level. So that is why we have. And then now we have also this stuff also collected in this kind of container. That is non-decomposing materials, plastics, bottles, and all the like, that we put it here. Now our interest was, like, we are looking at our composting material, which are now ready to be taken and mixed with other feedstocks to be loaded onto the biogas plant to give us gas. Now from the dome, you can see the gas pipe. You can see there's a gas pipe there with a red capping. That is the gas line from the dome all the way then it moves underground. It moves underground to this point here. Now this point is what we term as a gas testing area. This is the gas testing area. Now you can see this pipe moves, it goes all the way to the kitchen. The pipe which is going to the other side, it goes all the way to the kitchen. And now I can bring it. Now I want to do some kind of lighting here. What is happening here? We made this provision for gas testing, but we have a plan to put a table here and the desalvarizer plus the cooker, where we'll be able to be testing for people on excursion on how the biogas works. You can hear that noise. This already that's a flame. It is colorless. You can't see it simply because you can see it there. There's a reddish flame there, but it is blue. That's why it is not visible. There's a lot, and imagine I've not gone halfway. If I do halfway, it will shoot all the way to the other side. That shows that there's a lot of gas in the biogas plant. Can you see there? Can you see the kind of pressure we are talking about? This is it is now halfway. If I open the full, it made burn things on the other side. You can see the flame, the way it is jumping all the way. Now, this is a really this is a monster, a really monster biogas. You know, looking at the kind of pressures that it has. Now, as you are looking at that, here we have what we term as water trap. There's a special water trap there. You can check there. That is a special water trap. The gas line is coming from the other side. It's coming here. There is a special container there. You can see, which is grayish in color. Above it, there is the gas outlet coming out. Then below it there, you can see the gate valve, which removes water. Wherever, you know, during biogas formation, there is water which forms. So we normally do what we term as we remove the water periodically when it comes, when it accumulates inside that container. You see, this is the container we are talking about. So then, if you can allow me now, put it off. Now at this juncture, you can see the gate valve there. Then now this is the green pipe connects. There is this which enters through this. This is a desalivarizer. The work of a desalivarizer is to clean the gas. Remember, biogas normally contains carbon dioxide. It contains hydrogen sulfide. It contains water vapor and all that. Some water vapor is got trapped at the water trap. And then now here, hydrogen sulfide, which is a very, very dangerous gas. It's very poisonous. It gets trapped in this desalivarizer. And again, the desalivarizer also shows the pressure, the doom. Now, you see here, you have the gas inlet into the desalivarizer and the gas outlet, which goes all the way to the burner, to the gauge. Look at that, the kind of pressure. In fact, it has reduced because normally it goes up to 12. And remember, something is very important which need to be captured. This biogas, because of the high production, we load it once in 2 weeks. Like now, we loaded it the other week. You know, it is now almost 1.5 weeks since we loaded. So, but as you can see, still the pressures are high. So now we cannot load it because the gas production is too high and our gas demand cannot match the production. So that's why we minimize the loading aspect such that we do not have excess gas which might end up destroying the dome. Because you can look at the kind of pressures we are talking about. These are a lot. The benefits of the whole process, you know, the whole process of converting waste into gas. One, you get clean gas. Number two, you get organic fertilizer. Number three, you clean up the environment because that kind of waste is now not there. Because you remember, when you talk about biomass waste is the main habitat for disease vectors. That is one. Number two is the main habitat for germs, whether bacteria, whether fungus, or any other protozoa kind of fungi. So it is a public health benefit if you can remove waste biomass in a very ingenious manner by converting it into a useful product or products. Like in this case, we are converting that waste into a clean gas, which is green energy and green fertilizer. That is the organic fertilizer. from there. And now the fertilizer goes for the growth of vegetables. So in other words, you are making, um, a kind of a symbiotic relationship between the vegetable growth, energy production, fertilizer production, all the way to the waste conversions. So you are utilizing your waste. And imagine, while I had not started producing this gas, there were so many like animals which were not mine. You are talking about cats, you are talking about dogs, rampaging around here. Now they cannot manage to rampage around because there is no food for them. I've already now converted this waste. And again, the environment around, I'm not dirtifying the environment around because I'm converting this. And imagine if everybody could do that, then we would not have waste in the environment. And we will have nutritious kind of, vegetables. That is sustainable living. You see, you live in a very sustainable manner. I'm not buying gas. That's another advantage. That's like you, the LPG. You may see here, I have LPG. You can come over here and see the LPG is here. That's a 13 kg gas, which I stopped using. In fact, it's 3/4 full. It is 3/4. Actually, it's almost full. It's more than 3/4 full. So the moment I started using biogas, I stopped using it. It has now almost a year. It has stayed here almost for a year. Now you can see the piping. And now you can also see, you can now see the kind of flame it's producing. You can be able to compare with the kind of flame the biogas is producing. So I abandoned this for better gas, which is renewable in nature, converting my waste. Because within the 2 weeks span period, we could have collected enough kitchen waste for use to produce our biogas. This is LPG Mark U, and that is biogas. Now, definitely, there is a great advantage compared to LPG, for instance. Now, that gas I produced it from waste. Otherwise, which I could have thrown away. Okay, it's like if I bought the food, vegetables, I do peels. Instead of throwing away those peels, I'm converting them to biogas for cooking. But you see, if you don't have biogas and you are relying on LPG, it means you are throwing away those waste, and again you are dipping into your pocket. You go out to buy gas. But in that other case, I'm not buying anything there. I'm just converting a waste into the only cost I incurred was during the construction of the whole system. Okay, which return on investment is normally actually within 1 year to 1.5 years, I could have recouped, I could have returned all that cost. That is the period within which one score. If it goes further than that, it's just 1 year, and no 2 years. So we could have scored that. So there is a whole benefit. Now, somebody is using electricity to heat the water for showering. Electricity tariffs in Kenya are quite high. You cannot compare with, gas for heating purposes, for cooking purposes, vis-a-vis electricity. Electricity would be so costly compared to that kind of gas. Okay, you can, as you saw, it is very blue, very hot, and the flame heights are quite high, the pressures are quite high. Bearing in mind, these are optimized. This kind of biogas is optimized. It's not a normal biogas system. I have come up with a technology of optimizing biogas systems. That's why you are seeing this biogas will not resemble other biogas systems. It's because I've done new energy technologies, and that is what has enabled me to kind of catalyze the whole process of this kind of biogas system. Now this biogas is 12 cubic meter, and it costed between 170,000 Kenyan shillings to 200,000 Kenyan shillings on a gross basis. 200 when it is gross in the sense that I had to factor in my man hours I used to supervise the whole entire exercise. But what went on to the real construction materials, the labor costs, it was 170,000. But still, the production, the cost can come down depending on the availability of the raw materials. You see, that is the 12 cubic meter. That is the cost. And when you convert 170 into dollars, how much is that? That is 170 US dollars. Okay, to 200 US dollars. Hope my conversion is right. Yes?
It's 17,000.
17,000?
US dollars. No, it's 1,700.
It is 1,700 US dollars.
Yes.
Is that true? That is 170,000 is actually, yeah, that's true. It's 17 what? 1,700. That is 1,700 US dollars. Sorry, US dollars to 2,000. Is it?
Yeah.
To 2,000 US dollars. Yes.
And what are your long-term plans of this project?
Now, this project, I did it as a sample. You can talk about as a sample. As you can see, as you saw out there, I've fenced off a place. It's an excursion area, where people can come, do excursions, see how the biogas plant is performing, and then they give me a tender because I'm a biogas, or a renewable energy, consultant. I'm a renewable energy consultant, so I built that so that people and all clients can come and see a model biogas plant and its performance and the prowess of the technology, the new energy technology I have come up with, so that they can be able to appreciate and give me the consultancy and build for them the biogas plant which can produce like what I have here. Yes, that is the long-term plan. I'm entrenching fully into consultancy. Remember, schools are really using a lot of firewood. And when I look at it, if a school can manage to produce biogas from human waste, remember the kind of population schools have. They have so many students and so many staff. And they are having a problem of their toilets getting filled up. So, since I have the technology, if they get my consultancy, I can be able to produce for them a biogas from human waste. And you see, that's a sustainable energy because the feedstock is there, so long as students are there and staff is there. So, and again, they will stop buying this kind of firewood, causing environmental hazards, cutting down trees. Again, biogas is far much cheaper for them to use than using firewood, which is an unhealthy hazard because of the kind of smoke. Did you see any smoke here? Biogas does not produce any single smoke. You see, this is total efficient combustion process. And of course, you take a shorter time to cook. So those people, those guys in schools or institutions, institution kitchens, they normally take long, and you see they inhale a lot of this kind of emissions, which ends up affecting their health. So in that scenario, it means if they can be able to get this kind of technology, and again they have feedstock, which is human waste, then they can generate energy. They will save a lot. They will increase the health of the people who are working in the kitchens. They will cut down on costs. They will again shorten the period within which they are operating within their kitchens. Any further questions? So now I'm all out. This is a mature technology already, because already I've practiced it on my own project, and it has succeeded. And it is high time now people should know that they can tune their biogas like I'm tuning this. You know, you may put it on or you put it off. You can, in other words, what I mean, a biogas plant. Imagine how you can put it on hold, your biogas plant, from producing, and you can put it to maximum production. You see, those are the kind of technologies we are talking about. Like that biogas, when I don't want it to produce gas, I stop it. When I want it to produce, then I just tune it to start producing. You see? So that is the kind of technology we are talking about. That a biogas plant that you can tune. You can be able to, control its production to maximum or to minimum. You are able to control. Okay, these are the kind of systems now wanting to launch, and I'm out to roll them out to society, to community, such that we help, mitigate the cut down of trees, and of course, the destruction of the environment. And in a long term, it will mitigate issues of climate change. That's what we have. I've started a nucleon in the sense that I'm creating an excursion center already, which is about to get completed. Already the biogas plant is up and running, and the technology is quite mature to be rolled out. And now people, so soon they will start coming for excursions, and of course they start embracing this kind of technology. How beautiful is it when you manage your technology? That feel you will get it once you come to my level, that you have your biogas plant, you've fired your kitchen with green and clean energy from your own food waste you are generating. Imagine what kind of sustainable living is that? Very beautiful kind of stuff. So I'm urging that whoever is watching this video should reach out to me, and we be able to construct the kind of biogas and get to employ the kind of biogas technology that already I've come up with. Okay, wherever that person could be.